In this video, we learn about AC transients, analysis of RL series circuit. In this circuit, it consists of a switch and a resistor, inductor and a voltage source. It is given by Vs equals to V cos of omega t plus theta. For this circuit, we apply KVL. That is, sum of voltage sources equals to sum of voltage drops. Here Vs is given by V cos of omega t plus theta and Vr is nothing but R into I of t. The voltage across inductor is given by L into di of t by dt. Writing this equation into a simpler one, that is di of t by dt plus R by L into I of t equals to V by L into cos of omega t plus theta, treating it as equation 1. For this above equation, it consists of two parts. That is, first one, particular integral, and the second one is complementary function, and these things are denoted by IPI and ICF. We know ICF, that is K1 into e power minus of R by L into t. This equation we got from step response. Now let the particular solutions can be obtained by using undetermined coefficients. Let IPI equals to A cos of omega t plus theta plus B sin of omega t plus theta, treating it as I of t, and integrate and differentiating this equation, we get I dash of p, that is minus A sin of omega t plus theta into omega plus b into omega. What is the derivation of sine? Cos. Minus A omega sine of omega t plus theta plus b omega into cos of omega t plus theta, and it has di of t by dt, and treating it as equation 2. Now substituting IPI dash, that is di of t by dt, and IPI, that is I of t, in equation 1, we get minus A omega sine of omega t plus theta plus b omega cos of omega t plus theta plus R by L into A cos of omega t plus theta plus b sin of omega t plus theta, and this equals to V by L into cos of omega t plus theta. Now writing these terms like sine terms one side common, minus a omega plus ar plus br by l into sine of omega t plus theta plus ar by l plus b omega into cos of omega t plus theta. This equals to v by l into cos of omega t plus theta. Now comparing sine and cosine terms. That is, we get minus a omega plus br by l equals to 0 and ar by l plus b omega equals to v by l. By simplifying, we get a value. A equals to br by omega l, b equals to v into omega l by r square plus omega l whole square. Now substituting b value in a. Therefore, we get a equals to v omega lr by r square plus omega l whole square into omega l. Now substituting the values of a and b in IPI equation. That is, we get IPI equals to, what is a? BR by here we get this cancelled. A equals to VR by R square plus omega L whole square. VR by R square plus omega L whole square into cos of omega t plus theta plus V omega L by R square plus omega L whole square into sine of omega t plus theta. Let us consider, let k2 cos phi equals to VR by R square plus omega L whole square and k2 sin phi equals to V omega L by R square plus omega L whole square. Now to find k2 value and phi value, dividing k2 sin phi by k2 cos phi. By dividing we get this k2 k2, v and this denominator. Now sin phi by cos phi, tan phi, that equals to omega L by R. Phi equals to tan inverse of omega L by R. Now squaring k2 sin phi, and by squaring k2 sin phi and k2 cos phi and adding, we get, by squaring k2 sin phi and k2 cos phi and adding, we get k2 square sin phi plus k2 square cos phi equals to v square omega square L square by R square plus omega L whole square plus v square r square by r square plus omega l whole square and whole square. K2 square, when we common this term, we'll get sin square pi plus cos square phi. And the same denominator, here sin square pi plus cos square pi equals to 1. And when we are commoning v square term, and this is one time cancelled. Finally, we get K2 equals to v by under root r square plus omega l whole square. And finally, we get IPI equals to v by under root r square plus omega l whole square into cos of omega t plus theta minus tan inverse of omega l by r. Therefore, I equals to ICF plus IPI, that is complementary function plus particular integral, that is I equals to k1 into e power minus r by l into t plus v by under root r square plus omega l whole square into cos of omega t plus theta minus tan inverse of omega l by r. Here we need to find k1. To find k1, we need to consider initial conditions. That is at t equals to 0, I equals to 0. Therefore, we get overall equation I equals to minus e into minus r by l into t plus v by under root r square plus omega l whole square into cos of theta minus tan inverse of omega l by r plus v by under root r square plus, and finally we get equation I equals to minus e power minus r by l into t plus v by under root of r square plus omega l whole square into cos of theta minus tan inverse of omega l by r plus v by under root of r square plus omega l whole square into cos of omega t plus theta minus tan inverse of omega l plus r. I hope you understand.